So when we're talking about securing AI systems, especially in really sensitive environments, we're not just talking about the usual stuff like firewalls and encryption. No, we're talking about something way more fundamental: how we actually design and manage authority itself. It's all about moving from just giving access to creating deliberate, traceable authority. Let's get into it.
This is such a critical point to really let sink in. We have this image in our heads of a cyber attack being this one big, explosive Hollywood moment. But the reality? It's usually a lot less cinematic. The real story, the one that matters, often starts way, way earlier, with tiny decisions nobody paid much attention to.
And there you have it. That's the root cause. It's not the big, dramatic breach. It's the slow, subtle erosion of control. It's the fuzzy, unclear permissions. It's that one user who has access to everything just in case. And it's the dangerous assumption that we can just trust our internal systems by default. These are the cracks where major disasters are born.
Okay, so how do we actually get this right? Well, we need a map. We need a way to see and manage how authority flows through a system, a way to make this abstract idea of control something we can actually look at and work with. And this is our map. Now, don't worry about understanding every single box and arrow right now. That's not the point. The main takeaway here is that this diagram, what we call the IT/OT control plane, shows us how all the different parts of a system talk to each other. And this is the crucial part, where we can enforce the rules. It's all about separating the thinking parts of the system from the doing parts. Now, at the very heart of this map is a pretty simple idea: access control. It's basically the rulebook that governs every single interaction. Who gets to feed data to the AI, who is allowed to see what comes out of it, and maybe the most important question of all, who has the authority to let the system take an action in the real world?
If you get this wrong, you've got a massive problem on your hands. Authority, which should be super precise and deliberate, just starts to leak. It spreads across the whole system without any clear intention, creating all these pathways for failure that you never designed and, frankly, you can't control.
So, to prevent that from ever happening, we rely on three foundational principles. You can think of these as the absolute non-negotiable rules of the road for building any secure system.
Pillar number 1 is attribution. What does that mean? It means every single action, every query, every command, every little change has to be tied directly back to a unique, identifiable source. It could be a person, sure, but it could also be an automated service or another process. The one thing it can never be is anonymous.
And this is exactly why using those shared or generic accounts, like admin, is so incredibly dangerous. I mean, if you don't know who did something, how can you possibly have accountability? You can't. In regulated industries, this isn't just a bad practice, it's straight up forbidden. Attribution is mandatory, period. Okay, our second pillar is access control. But it's really important to get that this isn't just about, letting someone in the door. It's not a permission slip. It is the very mechanism we use to enforce boundaries and make sure that every actor in the system has the exact authority they need and not a single bit more. We can actually see this in action right here on our map. See these highlighted amber boxes? These are what we call approval gates. Think of them as explicit checkpoints where a request to do something is either granted or denied based on the rules we've set. This is where authority gets handed off formally and traceably.
All right, our third pillar is all about preparing for when things go wrong. Because eventually they will. And to do that, we have to understand a concept called blast radius. Basically, if one component gets compromised or just fails, how much of the system around it is affected? How big is the explosion?
The main way we limit that blast radius is through segmentation. We build walls. We create clear, enforced boundaries between different parts of the system. The classic example is that hard line between the corporate IT systems, email, servers, and the operational technology, or OT, that's running a physical process like a factory floor. And this illustrates that concept beautifully on our map. Just look at that divide between the IT systems on the left and the OT systems on the right. A failure in some IT analytics service can't just jump over that line and shut down a manufacturing plant. That boundary contains the problem. It keeps it from spreading. Now, this is especially vital for AI. Why? Because AI models are designed to pull in data from all over the place. Without strong segmentation, that AI system becomes a super connector for risk. A failure in one area could be amplified and spread to every other area the AI touches. Segmentation stops that cold. Now that we've got the principles down, Let's tackle a couple of really dangerous assumptions that teams make all the time when they're building these systems. First, there's this belief that just because the AI is running on a secure platform, the AI application itself is automatically secure. That is false. Security has to be explicitly designed for the application. And second, just watching what a system does, monitoring it, is not the same as protecting it. Protection requires active enforcement at those boundaries we just talked about. So let's put it all together into a practical blueprint. What does a system that is truly secure by design actually look like? Well, an effective design really has 5 key components. It all starts with least privilege, giving every user and every system the absolute minimum access they need to do their job. It uses role-based controls to manage that. It enforces the network segmentation we just discussed, and it defines explicit trust boundaries so nothing is ever trusted by default. And finally, and this is absolutely critical, it's never done. Security requires continuous review and adaptation. And just to be perfectly clear about the point of this explainer, we are giving you the principles to help you reason about risk. We're getting you ready to have the right conversations. What we are not doing is telling you which specific tools to use, and we are certainly not approving or authorizing any specific system or deployment. That responsibility always stays with the engineering and security teams. If you take away just one single thing today, please let it be this. Security is not a feature. It's not something you can just bolt on at the end of a project. It is the fundamental design of the system itself. It is, quite literally, the engineering of control. And that brings us right back to where we started. By thoughtfully designing how we grant and constrain authority through good access control and segmentation, we make sure that the inevitable small mistakes, like a misconfiguration or a bit of bad code, remain just that, small. We prevent them from cascading into one of those catastrophic failures. That is what security by design is all about.